Okay, so let's continue on here now. So now what we want to do is find the remainder without dividing. So if we want to divide 3x squared minus 5x minus 2 by x minus 2 and just find the remainder, we're then going to take this, take the opposite sign of that constant and substitute it into the polynomial to find p of 2. Then what we're going to do is do the same thing here. We rearrange this by setting this equal to 0 and solving for x, and that will give us negative 3 divided by 2, which we substitute into this polynomial here. Okay, so go ahead and do that. Pause the video and check back in a second. Okay, so checking back in here, once we have evaluated p of 2, we see that we get a remainder of 0, or a result of 0, which means the remainder of this division. And then when we divide this polynomial by 2x plus 3, or in other words, we substitute in negative 3 halves in for x of the polynomial, we end up getting negative 37 over 4. So the question is here, what does that remainder of 0 actually mean? Think about when you divide and you don't get a remainder. What does that mean about the divisor in relation to the dividend? So that actually means, because there's no remainder in this case, that means that the divisor is a factor of the dividend. Okay, just like if you were dividing 20 by 4, 4 is a factor because there remains no remainder. Okay, so here comes now the factor theorem that comes right from the remainder theorem. If we have a polynomial function and it has a factor, x minus k, then p of k will give you 0. Or otherwise, if p of k equals 0, that means x minus k is a factor of the polynomial. And the same thing goes if you have a coefficient in front of the x. If p of k divided by j gives you 0, then this jx minus k is a factor of p of x. So this if with two f's means if and only if. So the polynomial has a factor x minus k if and only if the evaluation of that polynomial at the value of k equals 0. Okay, so we want to now take a look at this following example, which is requesting us to see which of these binomials, x minus 1 or 3x plus 1, is a factor of this polynomial. Okay, so substitute in 1 for the polynomial for case A, and negative 1/3 in for part B to see if either of those are polynomials. Okay, so now that you've had a chance to evaluate this polynomial at 1 and at negative 1/3, we see that p of 1 gives us 0, which means that x minus 1 is a factor of this polynomial. And you found that p of negative 1/3 leaves you with 32 over 9, which is not 0, which means that 3x plus 1 is not a binomial, or sorry, not a factor of this polynomial. Okay, so now what does all this mean? Well, like we said in the goal, we're trying to make connections between the polynomials and the binomials that we're dividing by. Well, now that we see that we're using the factor theorem, or the factor theorem is developed from finding the remainders of division between some polynomials and the binomials. Now that we have the factors, we can then continue dividing to further factor polynomials that were previously very difficult to factor. So we factored quadratics before, we factored certain polynomials of degree 3 using grouping in the past, but we've never actually done any factoring of more complicated polynomials. So what we're going to do now is we're going to now factor these completely, to get them down into complete factored form, which would then give us the zeros, which we would need to sketch an accurate graph. Okay, so that's the main thrust of this lesson. Okay, so now what we're going to do, when you're looking for factors, you're going to substitute in values that you choose into the polynomial, and you're going to evaluate one by one in order to find which ones equal 0. When they equal 0, that tells you that it's a factor, and then once you know it's a factor, you can continue to divide down to give yourself a more simple polynomial. Okay? When you do that, first of all, this value that you substitute in to the polynomial must be a factor of this constant term divided by the a value. Okay? Generally speaking, just take the factors of this constant value, because if it's not a factor of the constant, then it's not going to be a factor of the entire polynomial. So take factors of the constant first, positive and negative. So try positive and negative 1 first, then try positive and negative 2. In this case, positive and negative 3 will not work because they're not factors of 8. You would then skip over to positive and negative 4, and then you're finished. Those are all basically the factors of 8. I mean, you could go up to positive and negative 8, but if you haven't found the factor by the time you get up to positive and negative 4, then chances are you won't get a whole number or a whole integer factor. What you would then have to do is you would have to do positive and negative factors of positive and negative 8 divided by factors of positive and negative 3. So you would then do, because using positive and negative 1, that would be a factor of 8 divided by the factor of 1 of the 3. And then positive and negative 2 would be 2 is a factor of 8 divided by the 1, which is a factor of 3. And then 4, positive and negative 4, those are factors of 8, or the 4s are at least. And then that would be divided by the 1, which is the factor of 3. If none of those work, then you must do positive and negative 1 divided by 3, then positive and negative 2 divided by 3, then positive and negative 4 divided by 3, to see if this would give you a 0. Okay, generally it won't go that far, but you just have to be prepared just in case you can't get an integer factor. Okay, so what I'm going to do now is I'm going to transfer that question onto, I'm going to say p of x is 3x cubed minus 2x squared minus 12x plus 8. So we're going to now use that to begin looking to see if we can find a factor. So we're going to try 1. Okay, so we work this out. So we get 3 minus 2 minus 12 plus 8. And when we add that together, we get negative 3, which does not equal 0. So x minus 1, because we're using positive 1 here, that tells us then that x minus 1 is not a factor of that polynomial. So now we try p of negative 1. Sorry, that should have been a cubed up there. In this case it didn't matter, but in this case it will matter for the second attempt here. So we get negative 1 cubed times 3 gives us negative 3. Negative 1 squared is positive, multiplied by negative 2, plus 12, plus 8. So here we get 20 minus 5, 15, which is not 0. Okay, so we got to go a little bit further here. Try p of 2. See what that gives us here. 8 times 3 is 24. Negative minus 24 plus 8. Okay, well you can see there 24 minus 24 and negative 8 plus 8, that will give us 0. So then at this stage, it's important then to say, therefore, x minus 2 is a factor of p of x. Okay, so because, sorry, I guess I should have put up here, let p of x equal this polynomial expression. Then we're saying once we've found that p of 2 equals 0, that means that obviously the opposite sign, x minus 2 is a factor of p of x. You need to state that.